Good afternoon, everyone.
Hey.
Welcome to Hardcore Debugging, and the title is very deliberately put that way. We actually originally debuted our debugging sessions here at TechEd back in 2008, and the reaction from the audience was something along the lines of, "What the hell was that?" And so we went through an exercise of figuring out how do we convey that we really mean it. We're going to go deep, and we are going to get really gnarly and geeky and nerdy. And Hardcore Debugging was a title that kind of summed it up. And I thought, what's the other problem that we have with Hardcore Debugging? And that is that I don't have an Australian accent. So we found a way to fix that part. But just to make sure you're prepared for what's happening, Hardcore Debugging is something we do internally at a Microsoft event called TechReady, and something we brought back to TechEd, and it was a great success last time. It is incredibly deep and nerdy. You're working with someone whose former job was as an escalation engineer troubleshooting the hardest problems to come into Microsoft, and because it clearly wasn't hard enough, he decided to go and write the code that then figures out how other people can debug stuff. And he's basically just going to be doing his job on stage. Every single time it's a different story. It's kind of like Case of the Unexplained, except for it's not wussy girl stuff like Mark Russ brings. This is the real stuff. So, with no further ado, my very good friend, Mr. Andrew Richards, is going to be debugging his way through this iteration of Hardcore Debugging.
Thanks, Chris. Woo! All right, so as Chris says, my name's Andrew Richards. I'm a senior dev these days instead of an escalation engineer, and I probably have the easiest job at Microsoft to now explain. You know when your PC crashes and it says, "Do you want to send this to Microsoft?" It comes to me. So I'm in charge of user mode crashes. I also host Defrag Tools. Defrag Tools kind of takes the hardcore debugging idea and presents it weekly at 9 a.m. every Monday. There is 90-plus episodes. We are aiming for 100, obviously. We've covered sysinternals to the nth degree, debugging tools for Windows. There's a 10, 15, 20-episode mini-series from around episodes 30-ish on debugging tools for Windows that explain how to learn debugging tools for Windows. Windows Performance Toolkit, there's about 20 of those. There's a whole lot of fundamentals about Windows internals, a whole lot of fundamentals about CLR internals. And not on the slide, there was a whole lot recently over the vacation break, on Windows Store apps, about 10 or 15. Watch that. Obligatory sysinternal slide, because I'm using Process Monitor today and ProcDump to help me get to root cause. The slide's there. Great book. Get it, buy it, enjoy it. All right, today we're going to go through 3 phases: collecting, debugging, and tracing. Because this is more of an IT-centric convention, we're not going to go to really through the Dev Center approach. If you want to see that, there's an equivalent talk at Build that I did, which was developer-focused, called Avoiding Windows Store Application Failures. So watch that one for more detail. We're just going to skim over that for a couple of seconds. We're going to go shortly over Windows error reporting, what it is, what it does for you, and how there's an associated corporate error reporting. We're going to go through sysinternals ProcDump, which I happen to code for Mark Rusinovich. And as of this morning, we just code signed version 7 that's been in development for about 2 years since version 6 came out. And we're going to be using version 7 today and all the new Windows Store application features that it has. Then we're going to get into the damn debugger and do some good console-based stuff, because I don't believe in GUIs. Then we're going to find that unfortunately, with the Windows Store applications, you don't get very far from a detail point of view, and so you have to augment the dump files through tracing. And ProcDump and Process Monitor in unison, who actually have a buddy relationship, can be used to help you with that. I'm going to mention Windows Performance Toolkit because it should be mentioned in every single deck that ever exists, because it is the best tool that Microsoft has ever produced, and it's free. Much like Mark would say, Process Monitor solves 80% of cases and the rest of the tools do the rest. Performance Toolkit solves probably 80% of the cases and all the other tools do the rest. Collecting failures. If you're a developer, the way that you can get failures and knowledge about your applications, be it phone apps or store apps, is to use the Dev Center dashboards. There's the 2 URLs. What those dashboards give you are slightly different views of the world. We're obviously unifying the store, so you can expect these to come together. So if you're actually a store application developer, this is how you can get the telemetry on your system. It's much like the old Watson and OEM OCA systems that are used to get information about desktop apps and device drivers. This is for store apps. What the Windows Store app can give you is your JavaScript crash rate, your CLR crash rate, which is also C++ crash rate, and also your app unresponsive rate. So one of the things about Windows 8 and 8.1 is touch as a first-class citizen. You haven't got a keyboard. And so when things freeze, you really can't go Alt F4 and stuff like that. And so a system called PLM monitors processes, and if they go unresponsive, aka hang, they get killed. What you'll see in the web page is a whole lot of graphs, then a whole lot of funky letters. Those phrases over there are the string representation of the issue coming out of Bang Analyze. I write Bang Analyze, so I'm the person who writes that. And then what you get on the far right-hand side is a download link allowing you to download the cab. On the phone, it's a bit more simplistic. You just get the graphs on the portal, and then what you can do is you can download export top stacks, which gives you an Excel web sheet that looks like this. And instead of doing it on the website, you end up with this column called download, and that's how you can get your cab files. What those files are going to have in them is very simplistic information. It's PII stripped, and it's just enough to get to an idea of where you are, not necessarily root cause. What we're going to go through now is how we go to the other extreme, and how in a corporate environment and how in an interactive environment with a consumer, you can get more information and delve deeper. Post-mortem debugging is a concept which has existed since NT3.1. Everybody remember Dr. Watson? Yep, yay. Unfortunately, he died. And Windows Error Reporting replaced him. So Windows Error Reporting is not that complex a concept. You have the NT loader, so when you run an executable, roughly Explorer says to the NT loader, please start notepad.exe. And it loads the module, and then it actually writes some code, like on the fly. It says, try, call the main function of Notepad, and then catch. And so if that application crashes, it falls into the catch block, which is part of the loader. The code that it falls into is Windows Error Reporting, and that's what causes WRF-folder.exe to be fired and stuff like that. If you want to delve into the reporting that it gives you, you actually can ask it to hive off dump files, and there's this key called local dumps that allows you to specify a folder and the type of file you want. Type 2 is full, type 1 is mini dump, so semi-useful, 0 is disabled, and 3 is custom, and there's a bit mask field that you can add to another one to make it a bit more slice and dice. In general, just go with full. And then dump count keeps it all sane and says, in this case, with a value of A, it keeps 10 dump files around. Now, regardless of whether, or ignoring of this setting, you have a secondary control over what happens to when a dump file or when a program crashes. Windows Error Reporting will read the AE debug key and will invoke whatever executable is there to attach to the process and do whatever it wants. Sometimes that's WinDBG, sometimes that's Visual Studio. Particularly if you install Visual Studio, you'll get that Visual Studio instance. One of the tools you can do, which is less invasive, is just in the background, is procdump. So procdump is, if you want a simple way of thinking about it, it's a replacement for Dr. Watson. What it can do is it can respond to a crash, and it can create a dump file for you. There's a subsystem called JIT debug info, which procdump knows about, and I don't think any other tool does, which means when you get the dump file, it actually has a little bit more metadata in it, and it's a little bit easier to use. So what I'm going to do right now is do a crash, and we'll see how procdump can kick in and do something for us. So I have a executable here that if I run it, straight away it crashes. And what you're seeing here is Windows Error Reporting popping up a dialog saying, whoops, and that's how you get the dialog. So what we want to do is capture that crash into this folder. So as I said, I'm using ProcDump version 7, which, as I said, actually is getting released today sometime. So maybe on systemternals.com tonight, you should be able to find it. This feature exists in version 6 as well, but this is how it works. So what we're going to say is, much like in WinDBG, when you want to have a full dump, you go .dump/ma. MA has the same type of idea here. And we want to say, when there is a crash, please capture me a full dump file. Because I didn't give it a file name, it uses the current directory. And all it's done is actually written out those two registry keys. It's accepted the EULA for us, and it has that funky -J on the end to do the work. So if we now do that crash, and we look for a flicker on the screen because it's quite fast, ProcDump's kicked in and caught a crash dump for us. Now, with the way that it interacts, it still gives you the ability to then go into a debugger. So it's actually like, I see it, I did it, I'm out of there. You can now try to do what normally would have happened. So let's have a look at this file. And ProcDump gives you a nice year, month, day, hour, minute, second, ISO format file name. It works out the name of the process and all that stuff, puts it on the front. Sometimes you will get two. I'm not going to go into the technical details. It's an artifact of Windows error reporting and 64-bit OSs and the C++ runtime. But sometimes you will get two dumps because there actually was two crashes. But most of the time there's two. Most of the time there's one. If you get that, in general, you can just delete the second one. All right, so this works for anything. It works for NT services. It works for desktop apps. It works for store apps, which is what we care about. So let's see if we can find a store app to play with, right? So I've got this application called Crash C# app. It may crash. Odds are good. And there you go. It does crash. So the writing to the dump file is done in the context of the application. So you need to write it into a folder that you have read-write access for everybody, right? So if you think about doing this centrally, just make sure that you put the ACL on the disk appropriately. All right. So we've collected dump files. -I installs it, -u undoes it. So if there happens to be a prior configuration, like Visual Studio, for example, it will restore what the previous values were. So we've done the demo. So now we're up to the debugging part. How are we going to crack these files open and actually determine what went wrong? So when it comes to store applications, there's a couple of blog items out there. This top one was posted on the developer blog when Windows 8 came out, and explains how to approach a Windows Store application. It explains some of the frames you'll see, the threads you'll see, stuff like that. What happened, though, unfortunately, is we realized that the way that the telemetry was coming in, and we couldn't work out root cause very well, and so we changed the subsystem in a release. And so a thing called stowed exceptions was invented. Has anybody heard of stowed exceptions? Completely nobody? Or one? That's really sad. So what happens is, instead of having this, what looked like kind of like a desktop crash, where the thread that of context is, it's actually all packed away asynchronously way over here. Because store applications tend to be an asynchronous issue. You have an HTTP request that crashes over here on a synchronous thread, and then at some indeterminate time later, it's propagated onto the UI thread, raised, and then never caught, and then down goes your application. So I wrote an NT Debugging blog article about this. It got released about December, about version 1. In March this year, 2014, stowed exceptions version 2 was released because we had a bit more data to add to the dump file. And I have a new blog item about that hopefully going live this week on the NT Debugging blog. Anybody heard of the NT Debugging blog? You like it? It's kind of nice and deep and geeky, yeah? I'm talking about that. I went into my drawer. I have to move office very soon. And I have all this junk in my drawer at work, and I went, well, I shouldn't throw it out. So anybody want a unified communications guy? There's a hand.
Technically, you are throwing it out right now.
Yeah. But it's not going in the bin. There's some guys over here. So I've got two Channel 9 guys. Oh, you guys. Oh, you're at the back. So you just in the red. Oh, that went nowhere. So I've got two Channel 9 guys because of the channel I do Channel 9. I'm going to ask questions for these ones. So how old is Channel 9? Yell out how old Channel 9 is. Someone over there said it first. You can fight over it. How old is Microsoft? Nope. 39. He said 39. It's about to have a midlife crisis. Yep. I didn't say it. All right, so all this data stuff that happened behind the scene kind of got a bit complex, so I wrote a debugger extension to help you do this. So I'm going to show you how to do it the hard way, and then I'm going to show you how to do it the easy way. There's a whole lot of tools on the Defrag Tools OneDrive associated with the show. This is just one of the tools that you can get from there to help you work along. When it comes down to the debugging tools, you need to download the Windows Software Development Kit, SDK. The debugger team is really awesome, and they do roll the debugger as fast as they can from a cadence point of view. I note this, that the 8.1 debugger was first published in October 2013 when 8.1 came out, but when the update came out during build in April, they revved it. And so if you actually download the SDK again, you actually will get the new bits of the debugger. Okay? So I mentioned that because they fixed a whole lot of things, added a whole lot of new features, and it's really cool. And here's the OneDrive. So there's a whole lot of XPerf scripts. So if you're a Windows Performance Toolkit guy, that's my script repository right there as a zip with about 30 or 40 scripts in it. And there's some debugger extensions there, and particularly this guy, this WinDBG guy, gives me a context menu that lets you jump into the right bit in this debugger when you're debugging. There's Defrag Tool shows on that around, just look for the Windows 8.1 SDK update episode from about 5 weeks ago about how to use those tools. When it comes to configuring the debugger, you need to have your symbol paths all set up. Everybody know what this is? If I can skip over it? No. So if you set these two variables up, you will cache files from this HTTP website to the cmysim folder. If you use the word SYM rather than symbols, and then also set the DBG help directory to the parent, some under the cover gooiness kicks in, and it will keep your hard drive a bit cleaner. And then you can decide whether you want a 1-tier or 2-tier index store for your cache files. You'll see how the first 2 letters of the file name are used for the subdirectory. So that way when you have bigger folders, your drive isn't filled with 1 billion folders, because it's like, 20 or 30 get reduced down to 1, and you'll find that your I/O access is faster. I do suggest that you compress that folder. It compresses to about 30%, and you tend to have enough CPU power to do the decompression of NTFS, so it actually tends to be less IOPS that use up CPU, and you'll find that your symbol resolution speed gets better. All right, so let's actually debug this guy. All right, so I'm going to do this by slides. Have the symbol server path set. That means you understand everything about Microsoft. I suggest you do a reload/force at the start, just so you don't get a whole lot of symbol spew while you're working, right? It kind of sometimes gets in the way. When you get an exception or a crash dump, you'll have this phrase, this dump file has an exception of interest stored in it. The stored exception information can be accessed via ECXR, exception context record. So there's 2 parts to a crash. There's the exception code that has the code, the address, all of the packed information, and then there's the context, which is all the registers at that point in time. And so you remember how I was saying that Windows error reporting kicks in with this bubble? Well, the crash happened here, and it gets percolated up to this bubble, which is nowhere near the crash. And then it actually creates a process, your process, like procdump, and then it looks at this process over there and takes a snapshot. So you're actually seeing the call, all the Windows error reporting code. And that's not really what you want. You want to move back in time to when the actual issue occurred. And that's what the .ecxr command does. And so you'll end up with something like this, a stack. So this is the stack we got for the application that crashed. When we look at the exception record, this is the E part of ECXR. The magic number is -1, which means read it out of the metadata rather than a physical address. You can see that it's got the magic code for CLR exception. It tells you what the H result was in the parameter 0, so 70005 for access denied. So if you're going to have a CLR dump, you need a debugger extension to rip that apart. You need something that knows how to look at the CLR. The debugger intrinsically only is native. It doesn't know about any additional frameworks. It doesn't know about .NET. It doesn't know about JavaScript, and so on. If you are on a machine where you have the same version of the CLR installed as the dump that was taken, you will load a DLL called sos.dll, son of strike, from the framework folder. If it's not, what you'll find is, as of the 8.0 or 8.1 debugger, we will go to the public symbol server and download the DLL for you, right? And so it will match the architecture, and it will download more than just SOS. It will download MS Core DACworks and a couple of other things, all the files required to make this work, and we'll load it from your symbol cache. So there's no more .load by SOS space CLR or MS Core Works. So once you've got SOS installed, you can run commands. So for the way that the dump is made, the PE command, print exception, doesn't need to be passed any parameters. What that means is find the last exception on this thread that the GC knows about. And as I said, with the way that the dump is taken, garbage collection hasn't happened, and so it's still there and preserved. And when you have Windows error reporting doing this and uploading the triage file for telemetry, it knows to keep those pages in the file. In this case, this is where we ran this store application and it crashed straight away. It got a unauthorized access exception, and I'll show that in debugger for 5 seconds. So here's our crash. Here's our sentence saying, oops. We do an ECXR to get to the right context. We do a K. I didn't do a reload, so all this junk's in the middle. And you can see it was trying to execute main, something to do with XAML, and then something went wrong. If we look at the exception, you can see the CLR side of this. You can see that it was in a program called crash store. It was in its main page, and it was actually trying to start the application. It was trying to initialize it, and then it failed. So what you want to do is look for evidence of why do I have access denied. The string up here, this guy, doesn't tell you what the object was, right? So because it's a managed application, we use a command called sos.dso, dump stack objects. And this is all the local variables, if you want to call it that, on the stack. And you can see that the unauthorized access exception is on the stack lots and lots of times. And there's nothing really else. These strings don't have actually anything in them. So at best, you can trace down the access exception. It defaults to, just dumping the object, so you can see the raw things. And here's the message. And you end up in the same situation you were before. So let's bring back this scenario and work out what you can do in this type of situation. We did that, didn't help us any. We're still clueless as to what the access denied is. So Mark makes everybody say this is a case of unexplained. Everybody gone for case unexplained before? Just go. It's fun. It's a good way of ending Tech Ready. That's Tech Ed. He makes you chant this 3 times. I'm only going to make you say it once. All right, so on 3, when in doubt. 1, 2, 3. All right, I've done my deed. All right. So what we're going to do is we're going to use Process Monitor to find out what went wrong. Except the EULA. And because this is a brand new session, I don't have to press reset, but in this case, I'm just going to press reset to make sure it's clean. Minimize it. We're going to crash that application. Came up, goes down. You saw proc dump kick in and make another dump file. And so we've kind of finished our work there, and we'll stop capture. And then we can use the tree view, Control T. It's in the menu somewhere. I don't know where it is. Don't really care. It's Control T. And down the bottom here somewhere, we can find it. Procman, where is it? Did I pass it? Is it up or down? I need crash. There it is, right here. So there's application running. Unsurprisingly, Windows error reporting kicked in. We're fault. It called procdump because it was a 32-bit app. Procdump used the 32-bit app that it is to dump the process. If it was a 64-bit app, you would see one more underneath that. It would extract procdump64.exe out of itself, and then you'd see that doing the dumping. Much like Process Monitor and Process Explorer have all the same concepts. So in this case, we just really want to know what crash store is doing. So we're going to do include process. I don't want the tree because I don't really care what procdump did. That wasn't the bug, right? So I'm just going to go include process. And now we're filtered down to all the traffic from that. And I'm not going to scroll through here. It's way too hard. So this is probably the best tool or menu item in Process Monitor, count occurrences. And what we're going to do is search on result, which is this column here. And we want to count how many things have happened. Well, we had an access denied in the dump file, right? So access denied is what we want to look for here. So if you double click on something here, don't press filter, that's a manual way of doing it. Double click on the item here, it applies it to the trace. And we're now down to, whatever that is, 10 rows. From experience, I can tell you that those .NET Framework ones are benign. It happens on every store application. It's just an artifact of the way store apps invoke the CLR. The C colon / one's kind of interesting, but it's just trying to open a file on C drive, which you shouldn't have access to, so that's good. Nobody's changed the ACL on C drive to make it less secure. And then, unsurprisingly, the one that we want to focus on is this bottom one. It's also the last one, which is what caused the crash, so it's kind of obvious to go for the last one. We're going to go jump to. So this is going to go to the registry keys. Oh, I wasn't happy with that. That was a bug. Did you see that? It's on tape, too. But I didn't have anything tracing it. Damn it. Mark and I have a bit of a tit for tat for bugs. All right, so this is the area that store applications exist in. Current user, software, classes, activatable classes. If you can just remember the first three and then press A, you're in the right location. So if you get to software classes and then press A, activatable classes is the first one. And then what you're looking at here is each application package that is installed. Store apps are delivered in packages. They contain applications. Everything that is non-Microsoft has a one-to-one relationship. If it's, and I think the only one that falls into this category is communication, we happen to have a lot in the communication app. The reason for that is if the calendar app needs to talk to the mail app and talk to the people app to share information, and the security boundary of a store app is at the package level. And so that happens to be the only one. Everybody else has to do one-to-one. So the one that we were doing is up here, and we had an access denied to this guy. So let's have a look at the permissions on this. And it looks kind of good. I'm the Defrag Tools user. I have full control. And I get it. What's wrong, right? I shouldn't have access denied. So let's have a look at a compadre and see if we can find what the difference is. Aha. There is this user or group called All Application Packages. This is part of the sandbox for store apps. You need to have this ACL granted to you, otherwise you can't read the registry key. And so cutting the investigation short, if you look at this level, you'll see that under advanced, inheritance has been disabled. And so there's two ways of fixing this. I could uninstall it, or in this case, I can say enable inheritance from the parents, press OK, and now from the package node, all application packages has been inherited down. And so if we run this application again, voila, Andrew Richards UI Design 101. That's as good as I get. So Process Monitor did not too much effort, right, to go from the dump file that has an access violation in it. It could have been a file not found. It could have been lots of things that Process Monitor has an equal trace for. A little bit of clever filtering, particularly the count values dialog is awesome. Particularly when you're trying to trace down file stuff. If you see, not only access denied, but UNC share type status codes, you know that's the cause. We did a jump to, found it in the registry. This is where all of the per user store information is kept. And remember this, because this is the same key how we configure debugging. And then you need to have the all application packages user on the object. All right, as I said, I don't do UI. So let's, I'm pretty sure we can all guess what's going to happen when I do this. It's going to crash. It's quite fast in the background. Proc dump kicked in, took another crash dump. So before it crashed because of the registry key thing, now we're crashing for another reason. There's the slide. So proc dump 7 averages a pretty good speed. So you can see that 164 megabytes in 0.2 of a second. So it's quite fast. All right, that's like gigabit speed to disk. All right, so this part is a lot of typing, so I'm just going to do it by slides. I don't want to waste my time trying to get the right syntax. This is all about stow exceptions. This is all about how we change the way we describe in memory a crash for store apps. This is what you basically only have now in the ecosystem. You have to go through these manifestations. So what happens is, regardless of how it crashes, you'll now get C000027B, which doesn't have any magic meaning, doesn't represent any string or anything. And even the debugger still doesn't have it as a known error string, but it is the stowed exception error code. And it always has two parameters. The two parameters represent the stow exceptions. The first one is an array of exceptions. Stow exceptions was invented to trace exceptions across processes. So if you want to have access to the disk or a couple of other things like the microphone and all that type of stuff, you have to actually do an RPC call into an SVC host, and WinRT does all this magic for you, but it's actually in a separate process that the work is done. Starting the microphone, enumerating your location device, all that type of stuff. And so the stow exceptions are bundled, and so as it crashes over here, it actually goes across the process layer and comes into your application, and you can have multiple of them. And it's very regular that you'll get more than one. If you want to work out what version it is, you can do this .formats mathematics, and there's an easier way in a sec I'll show you. And you can work out whether it's version 1 or version 2, so then you know how to interpret the data to the next level. If you don't have symbols, so you don't have access to the public symbol server, and you don't happen to have the PDE debug extension handling, you can at least get the H result. The blue and the yellowy orange color on the first row are the 2 pointers within that array. L2 says, which is the purple, says show me 2 pointers, what the L means. And then I've printed out the first 4 pointer worth of data out of each class or each structure, and you can see that both exceptions of error code 4001. If you actually have symbols, this is the approach that you take. The first thing you need to do is, much like we just did with those hard-coded POI commands is to work out what version of stored exceptions you have. There's a common header at the top of all these guys, which is this 8 bytes, and this is the class you need to cast it to. And you'll end up with a string that says either SE01 or SE02. Don't be surprised over the years if SE03 and SE04 and etc. turn up. Once you have the number, you know what class to cast it to. We have made combase.pdb, the private symbols of it are on the public symbol server. Right? It's one of the very rare symbols that we actually give out the private symbols for. And so that's why you can do all this data type querying. Normally with the public symbol servers, you wouldn't be able to do this. If you have a value of SE01, the structure is _v1. If you have SE02, it's _v2. So once you've got that far, you now can start casting it and getting streams and streams of data out. These two fields represent the error code, so what we found by pointer math, and the exception form is what style it is. The Y represents a bit, so there's OX for hex and ON for decimal. OY is bits. So if that bottom bit is set, it is a call stack. And then these other variables within the structure describe how the call stack is generated. Stack word size tells you the word size of it. I highly suggest if it's a 64-bit dump, run it in the 64-bit debugger, and 32 on 32, and ARM on 32. That way the DPS command will all line up. There's the pointer that you need to do, and the L3 comes from how many records, so how many frames there are. Unlike a normal call stack, this is just an array of function pointers packed next to each other. Right? With normal call stacks, it's like this, then a whole lot of local variables, and then another function. This is just an array of function pointers. There are no local variables in a store app in any dump file. We don't retain that information. So it does make debugging harder. You'll regularly get quite a shallow stack, 3 to 5, 7 frames, but you always will see originate language exception on the top. And this is the way that language projection moves from the language up top down into WinRT to the exception subsystem, and this is the interplay. And this is why there's all this memory mumbo-jumbo going on, because we have to go through the language projection layer. If it's a 02, it's error text instead. This guy I haven't seen one of these in 18 months, but if you get a 10 on the Y, the pointer is to just a straight Unicode string. All right, so when version 1 was released, that's all you got. You got an error code, and you got the stack. And the stack was the native stack. It wasn't the CLR stack. All you're seeing is internal metrics, which doesn't really help much, right? And you can make a weak logical jump to get to the CLR exception, and I'll show that in a sec, but it wasn't strongly deterministic. So in March, we changed the algorithm and added the structure and have added a couple more fields, and it's called the nested exception type and a nested exception. Nested exception type, much like the signature, is just a whole lot of ASCII. So when you do a dot formats, you end up with, this happens to be the other way around, LEO1, which is language exception object 1. There's also CLR1, STO, and Win32E. Currently only Leo is used. Leo represents a language intrinsic that is about an exception, where the CLR1 represents an object. So Leo is all about system.exception, roughly. So once you have that address, it's all convoluted, right? Because I've been doing this for months, every single day. Once you have that address, what you have is the location of a CLR system.exception derived object persisted in the GC heap. So in triage dumps and that type of stuff, we know to keep this information. You use a very, very rare command called dump CCW, which converts a CCW address, we kind of think of it as a pointer, to the underlying address. The DML on that output, so the hyperlink, does a dump obj by default. Because it's an exception, we actually want to use PE. So copy the address, and voila, you actually have finally got down to the CLR exception that killed you. Oh, come on. Now, do we all agree that sucks? That's been my life for 18 months. All right, so obviously I don't put up with that type of stuff too long, so I wrote a debugger extension. So, okay, MS PDE, it's just going to redirect you to that defrag tools OneDrive. It knows how to decrypt to version 1. It knows how to decrypt version 2. If 3 ever gets invented, I'll add that to it. Because it's a binary standard, I actually wrote it without symbols, right? So you can do this with no symbols at all, right? And PDE is a debugger extension called the prototype debugger extension. It used to be called procdump.ext because it used to be only to pull out procdump metadata that procdump had made in dump files, but it does way more than that now. It's got maybe 50, 100 commands. Every time I hit something that annoys me, I add it to PDE, and then at whatever cadence I decide, I release it. Current one's 9.3. It probably won't change for about 6 months at least. Use pde.help to see what's in it. So when you run pde.dump.exception, DSE, this is the report you get on a version 1 dump file. So what you're seeing at the top is the native stack, and the bold areas give you, well, there's only one on this one, but you'll get a bold repeat for each exception record. For version 1, we take this logical jump. If the H result in the stowed exception happens to match the H result of the last CLR exception on the UI thread, we assume that the two of them are related. There's no actual direct correlation there, but it's statistically high chance. The reason why it works is if the machine isn't under load, the awaited thread will get queued onto the UI thread, and then get executed, rethrown, and the thing will crash, which means the CLR exception ends up on the UI thread. If the process was under load, the awaited thread will be scheduled to a thread queue and will be on another thread. Now, unfortunately, with the way that asynchronous code works, the odds are if it's on another thread, it will be garbage collected before the dump is taken. And that's what drove version 2, because we lost this deterministic relationship. So in this case, no reference exception because of some authorization or authentication mistake, then drove into all this WinRT mangling code, and then you have your full stack. As of March, this is what you're going to get. You're going to get a version 2 output. And instead of saying, you'll see, it says right down below, last CLR exception matches H result. In version 2, it will say associated CLR exception. It's pulling it out of the nested exception member and doing all that dump CCW magic for you. And in this case, we happen to have two stacks. And we'll actually just do a quick demo of that so we can see it on the screen. So here's the crash that we had. Because I didn't do a reload first, that's why we got the orange in the middle. And so when I pressed crash, I did it through the screen. I used touch. And so you can see that this XAML app is handling some input. And this is the second state exception, right? We're going backwards in time to the present. And then what you'll see is it goes up through the NUI input, so it's doing gesturing type stuff. It actually treated it as a touch interaction. There's the gesture. And then it flowed through, treated it as a button press on the thing, fired the event on the CLR object that backs the XAML button, and then here's the button class doing onClick, and then it dispatched the code to my code in XAML to do whatever it does. And this stow exception, because of propagation, gets the same error code that was thrown from the CLR. It then hit the main page, and then in the click event on that thing, through a not implemented exception, and then we have the final WinRT language projection code that finishes the story off. So very clean, very fast. So whenever you get a dump file, bang DSE, done, finished, walk away. All right. Thank you. All right, so we saw DSE in action. So what exceptions do we see? So one of the benefits of being where I am, every single dump file that comes into Microsoft comes to my desk, or via my desk or something. And what I did is I just grabbed a random 1,000 from a random queue at a random time. So this is not representative of anything, but just take it as a rough guide. No reference exception, number one, not surprising. You've got to check, people aren't checking their return values of functions. XML exception is quite high. There's a lot of code in store apps that goes and talks to some cooking website or an RSS feed and just assumes that the XML coming back is well formed. And so XML crashes a lot because of parsing errors. Because of some of the language weirdities and language projection, some of the classes are typecast down to system.exception. That's just the way the casting works. And so system.exception gets an unfair amount of blame. It actually is a more inherited class that caused it. Interop services, COM exception. This is common in C# apps that are talking to C++ components, libraries. Very good example is DirectX. So a lot of people write their GUI like in XAML and C#, and then they call a DirectX backend to do the real work written in C++. Even though if something's Windows logo compliant, you'll find that the video card inside it will have the right DirectX version, so 10 or 11 or whatever it is. But people upgrade their machines, right, with their old GPU, that's DirectX 8 or 9, and it functions enough to get the desktop running and DWM's happy. But when a game tries to start some subsystem in DirectX, it throws in a not supported DirectX error code, and then the whole thing collapses. And that's what most of those are caused by. Invalid operation is just someone being stupid in code. Unauthorized access exception, that's what we got when we had the registry key hit. It's what you'll get when you hit maybe an ACL damaged on your file system. Store apps can't talk to UNC drives unless they're enterprise signed, so that's kind of rare. What you will see is when they're trying to talk to a website that they don't have access to. It's more of a web type call. Talking of web, net sockets and net web exceptions, they hit. We had one day where we had about a 12-hour window where we were flooded with crashes. And one of the big Fortune 50 companies, their DNS server died on the internet. You could not resolve their website. And so these applications were trying to phone home to look up some data, and you could not resolve www.contoso.com. It was just dead. And so web calls particularly need to be wrapped. You can hit an overloaded web server and get web exceptions. You can have bad routing causing socket exceptions. So be it. Argument not out of range, argument null, argument exception are all kind of self-explanatory. File not found. When you have 1 billion users, things go missing on hard drives. That's what causes that. And because it didn't fit in the top 10, I had to go to top 13. Not implemented exception. Come in at number 13, which is kind of an ironic number. I'm quite surprised to see that 1% of apps not having code implemented but going through the store. All right, so tracing failures. So as we saw, you get the CLR object sometimes, but the stack that you get in there is a tightly packed function array. So there's no local variables, right? And so what do you do now? How do you go further? So through luck, sometimes the UI thread is the same thread that dispatched the awaited call. So it sometimes can have some of this stuff hanging around. And there's a command called DPX inside PDE that kind of automates stack trolling. And what it does is it knows about stack bounds and stuff like that. So it knows about an obvious logical range of memory to scan. And it's equivalent of doing DPP, DPS, DPA, DPU, DPT, if it even existed, like DT command. And it also looks for trap frames and lost state exceptions, which I've never had to use, but it's coded anyway. So just have a look at PDX. And everybody who's seen PDX has gone, oh, where have you been? So we'll see what the reaction is today. I want that reaction, all right? Even if you don't believe it, I still want it, just for my... All right, DPX. So pretty fast, snappy. There's another command called SPX. You can search for like a string like Andrew in a 100 megabyte dump file in about 10 milliseconds. All right, I got sick of search being slow. It has to be a full dump file, which is kind of obvious because it's only big files that you care about. It actually uses some really funky, high-speed lookups inside the Debugging API that nobody ever uses. and will skip everything that's stupid to look for. So it will skip images, it will skip all the things, and only do private memory. And actually, I don't know if it's going to find it. Let's see. We'll look for, whoops. No, strings, sorry. SSZ, strings, SSZ. Now, that's how fast it was. It didn't find any, though. It's not working for him today. Demo glitches. But it does work. Anyway, if you want it to work, email me at dfractools@microsoft.com, and I'll put some effort into fixing it and work out what the glitch is. So what you're seeing here in DPX is everything it can find. And so it found some stored exceptions hanging around. It found restricted error. This is actually the class that is actually written in WinRT that actually does the interrupt between language projections and the CLR language and WinRT through language projections. This is actually how we move all the memory around. And so you can do a DT on that. You notice how this is blue on the front? So who hates debugging in COM because it's got interface pointers? Oh, come on, put your hand up. We all hate it, right? What this does is it unwinds the VF table and changes an interface pointer into the class that implements it. So even though this pointer points to somewhere, it doesn't point to the right address. And so PDX has recalculated the real pointer that you want so that when you do a DT on it, everything aligns. So that pointer was pointing about to here. And if you had cast it to the class that it is, you would have been off by 16 bytes and nothing would have worked. All right? So if you're a COM-type person, and you will become a COM-type person because that's what WinRT is, it just starts with the letter R instead of the letter C because it's awesome COM. All the bad stuff was thrown out, all the good stuff was kept, and that's what WinRT is. And so you can see the strings here from the class, and we can do some filtering. So we can say, DPX, show me all the Unicode strings. Show me all the ASCII strings. Show me all the data types. Snappy, right? All right, so that's DPX. Round of applause. There's SPX. You can give it a pointer or an expression like a class name, and it will find every single instance of that class name in the dump file in about 10 milliseconds. All right. So the next phase of tracing is to go to a little bit more invasive approach. We're seeing evidence at crash. So we're seeing all this awaited stuff lost. And as we showed right at the start, you can use file tracing, for example, also registry tracing with Process Monitor to track down a registry key that caused an access denied, for example, right? Much like that, ProcDump has the ability to emit exception tracing. So it gives you another vector into Process Monitor. And actually, it logs its events in Process Monitor. You actually have another field called exceptions that you can get. Obligatory mention of Windows Performance Toolkit. It is the king of tracing tools. I think there's like 40,000 providers. It is just awesome. It doesn't apply to what we're talking about today. But in other instances, say you're trying to track down a network glitch or an activation glitch or a PLM glitch, your ETW provider is the way to go. What is ProcDump? So, has anybody used ProcDump? So, version 7, as I said, has been in development for about 2 years, 18 months. Complete rewrite because, or refactor, I should say, because we needed to expose a couple of new abilities, which I'll explain. We've added debug logging as an exception target. And what that means is if someone does a debug output string and puts out some text in the debugger window, you can now filter on that. So when they say, oh, that wasn't good in their debug statement, you can capture a dump when they make that command. -E is unhandled exceptions, aka when you crash. -E1 is first chance exceptions. So that's every exception, native or CLR or JavaScript. So IE JavaScript, not Windows Store JavaScript, Chakra JavaScript. You can trigger, they're all deterministic triggers. You can trigger on high and low CPU. You can do that either between 0 and 100% scale, or if you say have 8 cores, minus u will make it between 0 and 800. Minus u and minus c combined, that value is the same value that you get in Performance Monitor, the CPU graph in there. You can do it on memory usage. So if your memory all of a sudden goes like this or dies off, you can do a dump on that. Everything's at a 1 second cadence when you're down the bottom here. You can use a performance counter. New to version 7 is support for 64-bit performance counters. Version 6 and below only supported 32-bit counters, which is quite handy. And hung window is when you get the not responding grayness around your app. When it comes to actually what you're putting onto disk, you can ask for a full dump, which is just every private page, every image page, and every map page, aka everything. If you want to constrain that and make it a little bit smaller, you can forego the image and map memory pages and just get private pages. That's what MiniPlus does. It actually has some more logic in there for Exchange and SQL and a couple of other things, but that's a different story. And then there's the traditional mini dump, which is good for seeing the stack, but it's useless to get to delve in deep. Minus n is how many you want, and filter minus f lets you be selective about the text that you want to trigger on. New to version 7, we've always had this minus r reflection, which means that we'll take a dump file while it's live. But the reflection API, quite frankly, was rubbish. It didn't really do its job. It missed memory, various other issues. And particularly for CLR applications, the one page that it missed was the main index for the CLR heap. And so you couldn't really use the dump. In 8.1, we introduced a thing called PSS, Process Snapshot. And the easiest way to explain it is think of VSS, Volume Snapshot, for the disk. What Volume Snapshot is for disk, PSS is for a process. And so at a point in time, you take a snapshot, and this is actually how Watson runs. Watson, or Windows Error Reporting runs. When something crashes, they reflect it, they PSS it, they clone it, and then they start taking a dump of it, and then they let the process that was crashing crash. And so in the background, for however long it takes, the dump is occurring, and then you can restart the application and continue on. You can put minus R on the command line on that minus I for AE debug. So yeah, thing crashes immediately, but the dumping occurs in the background. The reason for the refactoring is that we allow you to do up to 5 of those at the same time, so you can take 5 dumps at the same time while it's live. And so you can be using like Media Player, right, or Xbox Music or whatever, and we're taking dumps in the background, 100 gigabyte, 500 gigabyte dump files, or whatever, megabyte dump files. The entire capacity of the MP4 that you're playing, and playback will not stutter at all. Really good for non-invasive applications, like if you're trying to do an IIS server or something mission critical. Minus A is avoid outage. So the way that the refactoring works is it makes these dump slots, a dump queue, and it has up to 5 slots in it. But if there's more triggers than the ability to run the dumps to disk, when it gets to the limit, whatever number you put after the R, the default is 1, instead of sitting there and waiting for the dump to complete, it just throws the trigger away, avoid the outage. So there's a balance between, do you want the data or do you want an outage? And minus A is designed to be used in production scenarios. As far as the target's concerned, you can do it by PID, you can do it by process name, you can wait for a process name to turn up, you can do it for a desktop app, and more importantly, what we're going to talk about today, is you can do it for a Windows Store app. You can do it at the package level, or you can do it at the application level. When you do it at the application level, it will start the application for you. So it's like execute, where at the package level, it will wait for it to be started. So when you do this, you have to negotiate with a subsystem called Process Lifetime Management. PLM is the person who is in charge of the lifetime of store applications. And when you want to debug it, you need to add this debug information key to the registry through PLM APIs to say, take this guy out of lifetime management. Don't kill it if I suspend the process, because it's not hung. I'm busy with it, because it will kill the process from underneath you, and then your dump will be thrown away. The traditional way of doing this is PLM debug. Everybody heard of PLM debug? There was a ILL, instructor-led lab, about an hour ago called Windows 8 Modern Application Debugging or something, and they deep dived into PLM debug. Yeah, I don't know if they're recorded or not, but yeah, if there's another repeat of that, I suggest you go to it. So ProcDump doesn't have to deal with PLM debug because it has all that code baked into it. So when you run the command, it sets it. When the application runs, it gets traced. And when the application ends, ProcDump unregisters itself. So it's a one-shot hit. So let's play with that. So what I'm going to do is let process monitor run in the background so we can see. Is it tracing? Oh, so that's running in the background. And we'll see how process monitor happily works with process dump. And I'm going to grab, let's say Bing Maps for this. And there's a thing called the App User Model ID. And if you can't remember what that is, just type procdump, minus question mark gives you the help. And it says right down here, do you want some examples? And minus E gives you examples. And then there's a whole section here explaining what those things are, some strings that you can go search for and stuff. It's all under that activatable classes area. It's under the package, so you could use the package name right there. Or if you want to start the application, which tends to be in these MCA folders, you get the app user mode ID. So we'll grab the one for, Bing Maps. And what we're going to do is we're going to say, for every first chance exception, I don't want to capture it, so I'm going to set a filter that's unattainable. I want you to trace it for me, put the files into dumps, and start this app. Now, just to make things more interesting, I'm going to unplug my network so Bing can't talk to anybody, and hopefully we'll get some web things flying around. And what's going to happen is it's going to configure PLM, and you'll see some stuff fly down the screen. Maps is going to start. ProcDump in a new instance is going to negotiate with PLM, and the two of them are going to run in concert with each other, and you're going to see the tracing happen. So there's maps executing. Still pretty fast, not much effect on the performance. Did they actually execute it? Oh, I must have had a map still running. Let's do it again. Yeah, it's a little bit slower, so it definitely kicked in. And so, still responsive because we're just monitoring. And we have a new ProcDump instance. And here are all the exceptions flying by. So there was ProcDump has a built-in CLR exception engine. It's both a managed debugger and a native debugger. And it actually decrypts all of the CLR exceptions for you. So you can see there's a whole of aggregate exceptions, a web exception, which says right there in the name, rewrote name could not be resolved inst.platform.bing.com, right? So I don't even have to take a dump file at this point, right? The information's right there on the screen. But the information's also in process monitor. So if that application closes, let's say we'll just close him, well, this procdump's going to disappear, and we're going to lose it, right? You can't redirect it to a text file because you don't really have that control. And so that map application is going to suspend, and at some point it will die. It will definitely die if I kill it. Die. And then you can see that instance disappeared. And process monitor has been tracing this the whole time. Now, if you turn off everything, getting there. And we're going to turn on this last one, which is very rare. Most people don't look at this one. The reason why the profiling, I know we call it section, exists, is it makes these profiling events. And this is what gives you all the CPU graphs and the file tree and all that stuff. That's where all this information is stored. And that's why Mark generates them. And what I'm going to do is I'm just going to exclude them I'm not deleting it from the trace, I'm just hiding them. And what we get left with is actually proc dump events. So everything that came out on the screen in proc dump actually is an event in process monitor. It's kind of cool, isn't it? So here's that web exception to do with Bing.com. So if we turn on networking, we'll find the packet that failed, right? So you can do that type of correlation, particularly when it comes to things like SVC host. See, this is a good example of how a store application has sent an RPC call across to SVC host to then go and talk to the internet, because the application itself hasn't got direct access. It has to negotiate with someone else to do it. So there's the SVC host on the behalf of Bing.maps that's gone out in the wire. So let's grab some of these and see if we can do some fun things with it. So there was an aggregate exception in there. So we didn't really see what was inside because it had encompassed everything. So aggregate is enough wording to make it unique. I want full dumps and give me up to 100 of them, right? So this is running. Now, it's quite slow, and I'm touching the screen and nothing's moving. That's because dumps are being taken in the background, right? It's frozen the whole thing. And that's not really a great experience, is it? Right, it's kind of annoying. And it's also not very representative. You're screwing up all the timings of the app. So when it's trying to do, well, if I don't see this thing happening in 1 second, then I'm going to go down this code path. Well, you kind of want it to be consistent. And that's where that new -R option, so I can't even close it, right? And what you're seeing here is all these dumps being taken. And these are, what are these, 321 megabyte dumps taking 2 or 3 seconds each. So let's kill that, and we'll, as soon as you detach, it goes back to full speed. So it's not, you press Control-C, you log off, you close the console window, all those things will tell proc dump to, hey, get out of there, and put it back to undamaged. So let's kill that, and this time, instead of jamming everything up, let's really push my hard drive to the limit. We'll get it to do 5 at the same time, slamming the disk, but if you get overwhelmed, avoid the outage. Right? Now, this doesn't have to be a store application that I'm launching. You could be attaching to IIS, anything that is mission critical. So you could, instead of this big -X dumps on the end, you could just say W3WP and attach that process and see what's going on. So we're going to catch a dump whenever there's an aggregate exception. It boots. Man, why are you jammed? There it goes. And this thing is taking dump files in the background, and it still works. Kind of cool, huh? And that was the whole point of ProcDump version 7, was this non-invasive dumping technique. If we jump across to the output window, you can see up here, dump exception avoided, and tells you what exception we skipped. And it will avoid any trigger. It will avoid a CPU trigger. It will avoid like a memory trigger, performance counter, termination, all the different types that ProcDump has in it. The system is across all things. So if a whole lot of CPU things queued up, if you got filled up the dump queue, then the exceptions would be ignored, and so on. Kind of useful? Big change from version 6, much less invasive. What you will notice is, see that before we were averaging 3-4 seconds, 2-3 seconds. We are now in the 30-something second range. This is designed, PSS is designed to be non-invasive, and so we don't want your system bogged down taking a dump file, particularly with Windows error reporting, when you're trying to get the application up and running again. And so it uses a much lower I/O priority to disk. And so hence why the writing is much, much longer. And a 10x factor is pretty average to see. Now, the way that the snapshot is taken, how much time do we have? 5 minutes, is through memory cloning. So the amount of delta on the process defines how much you can do. So if you have like 8 gig of RAM and a 4 gig process, well, you've only got 3 or 4 gig left of space of differential, so you can't have too many at the same time. And what you'll see in proc dump is when you start hitting memory limits and you can't make the clone, it'll just say dump skipped because of failure to create snapshot. So be careful on massive servers which are using the large majority of the RAM. All right, we're getting kind of close to the end. We saw proc dump and proc mon integration. That's available in version 6, and it's even beefed up more in version 7. Version 7, nearly everything on the screen goes to proc mon now. In version 6, it was kind of a bit more selective. One last note on JavaScript. JavaScript applications, we're talking about Windows Store JavaScript applications, do not invoke the postmortem AE debugger. So proc dump will not be kicked in. It's just a way the architecture of JavaScript is done. It doesn't involve Windows error reporting. It uses a separate style of Windows error reporting. You still get a report, but instead of a dump file, you get a file called errorinfo.txt, and it just has this text, the line number onto the JavaScript, and the character on that line, and the exception information, all in a textual form. If you get a JavaScript cab down from the developer store, that's what you'll get, is a cab with just the text file in it. Proc dump can monitor these guys, but instead of seeing it as a JavaScript exception, like a proper intrinsic language exception, it sees it for what it really is, which is just one specific type of a native exception. And so it kind of looks like a straight native exception and just with a particular error code. You can still fire off it. It tends to have something.j as the, like a hex number.j as its name. So you can still fire on it, still have a filter. And then use DPX and stuff like that to scavenge out the strings of the text that went to the dump file. All right, let's wrap this up. Track resources. You've seen this 1,000 times already. At this conference, I'm missing a whole lot of stuff on here. I'm missing Chris's thing for Windows 8.1 security internals. Absolute must. 8:30 a.m. Thursday?
Yeah, bring aspirin.
Yeah, for Chris. There was a speech by Paula, I always get her last name wrong, Jablowinski. She did one this morning, 8:30, Trustworthy Computing, CIA. Watch that. She does another one tomorrow, which is about memory dump analysis and how much information you can rip out of a kernel dump file. That's really awesome. I've seen that before, and I know it's a really good talk. There was one on Monday called Visual Studio 2013 Debugger Tricks, and they showed, I think it was 60 debugger tricks in 60 minutes, and that was pure awesome. So if you're a Visual Studio debugger at any point, do that. Note on Visual Studio, this stowed exception hoo-ha, it was raised as a bane, and the June-July release update is going to have native visualization for stowed exceptions. So if you open up a dump file in Visual Studio, it will show you the stack and the CLR object underneath it. You still can't really dig in any deeper than that. You can't do stack trawling and stuff, but Visual Studio will have a visualizer. If you are a developer type person, there's my speech at Build, that's kind of like this speech with a developer focus. We look at the code that causes the exceptions. Check out Defrag Tools. On this topic, those episodes are kind of related or very related. Episode 85 is how to install the debugging tools for Windows in a way that you get the context menu, you get DML by default turned on, and all those other things. So all these funky things. It explains how to install the Windows Performance Toolkit, how to get the Windows Wintellect Package Explorer, which is awesome. It's kind of like the Process Explorer of the Windows Store world. You get that from wintellect.com. Blogs, there's 3 on how to debug this stuff. First 2 are roughly what I went through just today. The second one is going to get a part 2 and a part 3 on V2 and on PDE. The third one is developer focused and common mistakes that people are making in their code. Books, if you want to understand the mechanics of Windows RT, these 2 are fantastic. The one on the right in particular by Jeffrey Richter and Martin van der Sport. Martin's on my team and is the Windows runtime god in the reliability space. And then we are at the end. This track exists because you want for it to exist, right? Tell us in your evaluations what you want, right? We can do any topic you guys want. We can go to any depth you want. If you don't want to give us a 5, then please tell us why it's not a 5. That's the goal, and we want to please you at that level.
And actually, we were having a discussion on this beforehand. How we do this for our internal conference was to do it TED style. We bring up 3 or 4 people, we give them 20 minutes, debug a problem, move on to the next one to get some variety. So by round of applause, who thinks we should have one person and go deeper? Who thinks we should get a pile of people and try to go breadth? All right, so I won that argument, Andrew.
So expect to only see me for 20 minutes next year.
But we'll take it that, but definitely, yes. I mean, we actually brought this in once and took it away. It didn't hit. And we said, gosh, I bet we can make it work somehow. And we kind of kept at it and kept at it. And now I think we're at the point where we've got the right way to get the right audience, and we want to deliver on that. So if you want more of it, let us know, and let us know exactly how we could better serve you and give you the tools and knowledge you need.
All right, guys, have a good conference.
Good afternoon, everyone.
Hey.
Welcome to Hardcore Debugging, and the title is very deliberately put that way. We actually originally debuted our debugging sessions here at TechEd back in 2008, and the reaction from the audience was something along the lines of, what the hell was that? And so we went through an exercise of figuring out how do we convey that we really mean it. We're going to go deep, and we are going to get really gnarly and geeky and nerdy. And Hardcore Debugging was a title that kind of summed it up. And I thought, what's the other problem that we have with Hardcore Debugging? And that is that I don't have an Australian accent. So we found a way to fix that part, but just to make sure you're prepared for what's happening. Hardcore debugging is something we do internally at a Microsoft event called TechReady, and something we brought back to TechEd, and it was a great success last time. It is incredibly deep and nerdy. You're working with someone whose former job was as an escalation engineer troubleshooting the hardest problems to come into Microsoft, and because it clearly wasn't hard enough, he decided to go and write the code that then figures out how other people can debug stuff. And he's basically just going to be doing his job on stage. Every single time it's a different story. It's kind of like Case of the Unexplained, except for it's not wussy girl stuff like Mark Russ brings. This is the real stuff. So, with no further ado, my very good friend, Mr. Andrew Richards, is going to be debugging his way through this iteration of Hardcore Debugging.
Thanks, Chris. Woo! All right, so as Chris says, my name's Andrew Richards. I'm a senior dev these days instead of an escalation engineer, and I probably have the easiest job at Microsoft to now explain. You know when your PC crashes and it says, do you want to send this to Microsoft? It comes to me. So I'm in charge of user mode crashes. I also host Defrag Tools. Defrag Tools kind of takes the hardcore debugging idea and presents it weekly as ever exists, because it is the best tool that Microsoft has ever produced, and it's free. Much like Mark would say, Process Monitor solves 80% of cases and the rest of the tools do the rest. Performance Toolkit solves probably 80% of the cases and all the other tools do the rest. Collecting failures. If you're a developer, the way that you can get failures and knowledge about your applications, be it phone apps or store apps, is to use the Dev Center dashboards. There's the 2 URLs. What those dashboards give you are slightly different views of the world. We're obviously unifying the store, so you can expect these to come together. So if you're actually a store application developer, this is how you can get the telemetry on your system. It's much like the old Watson and OEM OCA systems that are used to get information about desktop apps and device drivers. This is for store apps. What the Windows Store app can give you is your JavaScript crash rate, your CLR crash rate, which is also C++ crash rate, and also your app unresponsive rate. So one of the things about Windows 8 and 8.1 is touch as a first-class citizen. You haven't got a keyboard. And so when things freeze, you really can't go Alt F4 and stuff like that. And so a system called PLM monitors processes And if they go unresponsive, aka hang, they get killed. What you'll see in the web page is a whole lot of graphs, and then a whole lot of funky letters. Those phrases over there are the string representation of the issue coming out of Bang Analyze. I write Bang Analyze, so I'm the person who writes that. And then what you get on the far right-hand side is a download link allowing you to download the cab. On the phone, it's a bit more simplistic. You just get the graphs on the portal, and then what you can do is you can download export top stacks, which gives you an Excel web sheet that looks like this. And instead of doing it on the website, you end up with this column called download, and that's how you can get your cab files. What those Visual Studio instance. One of the tools you can do, which is less invasive, is just in the background, is procdump. So procdump is, if you want a simple way of thinking about it, it's a replacement for Dr. Watson. What it can do is it can respond to a crash, and it can create a dump file for you. There's a subsystem called JIT debug info, which procdump knows about, and I don't think any other tool does, which means when you get the dump file, it actually has a little bit more metadata in it, and it's a little bit easier to use. So what I'm going to do right now is do a crash, and we'll see how procdump can kick in and do something for us. So I have a executable here that if I run it, straight away it crashes. And what you're seeing here is Windows error reporting, popping up a dialog saying, whoops. And that's how you get the dialog. So what we want to do is capture that crash into this folder. So as I said, I'm using procdump version 7, which, as I said, actually is getting released today sometime. So maybe on systemternals.com tonight, you should be able to find it. This feature exists in version 6 as well, but this is how it works. So what we're going to say is, much like in WinDBG, when you want to have a full dump, you go .dump/MA. MA has the same type of idea here. And we want to say, when there is a crash, please capture me a full dump file. Because I didn't give it a file name, it uses the current directory. And all it's done is actually written out those two registry keys. It's accepted the EULA for us, and it has that funky -J on the end to do the work. So if we now do that crash, and we look for a flicker on the screen because it's quite fast, procdump's kicked in and caught a crash dump for us. Now, with the way that it interacts, it still gives you the ability to then go into a debugger. So it's actually like, I see it, I did it, I'm out of there. You can now try to do what normally would have happened. So let's have a look at this file. And procdump files are going to have in them is very simplistic information. It's PII stripped, and it's just enough to get to an idea of where you are, not necessarily root cause. What we're going to go through now is how we go to the other extreme, and how in a corporate environment and how in an interactive environment with a consumer, you can get more information and delve deeper. Post-mortem debugging is a concept which has existed since NT3.1. Everybody remember Dr. Watson? Yep. Yay. Unfortunately, he died. And Windows error reporting replaced him. So Windows error reporting is not that complex a concept. You have the NT loader, so when you run an executable, roughly Explorer says to the NT loader, please start notepad.exe. And it loads the module, and then it actually writes some code, like on the fly. It says, try, call the main function of Notepad, and then catch. And so if that application crashes, it falls into the catch block, which is part of the loader. The code that it falls into is Windows error reporting, and that's what causes WRF-fault.exe to be fired and stuff like that. If you want to delve into the reporting that it gives you, you actually can ask it to hive off dump files. And there's this key called local dumps that allows you to specify a folder and the type of file you want. Type 2 is full. Type 1 is mini dump, so semi-useful. 0 is disabled. And 3 is custom. And there's a bit mask field that you can add to another one to make it a bit more slice and dice. In general, just go with full. And then dump count keeps it all sane and says, in this case, with a value of A, it keeps 10 dump files around. Now, regardless of whether, or ignoring of this setting, you have a secondary control over what happens to when a dump file or when a program crashes. Windows Error Reporting will read the AE debug key and will invoke whatever executable is there to attach to the process and do whatever it wants. Sometimes that's WinDBG, sometimes that's Visual Studio. Particularly if you install Visual Studio, you'll get that at 9 a.m. every Monday. There is 90 plus episodes. We are aiming for 100, obviously. We've covered sysinternals to the nth degree, debugging tools for Windows. There's a 10, 15, 20 episode mini-series from around episodes 30-ish on debugging tools for Windows that explain how to learn debugging tools for Windows. Windows Performance Toolkit, there's about 20 of those. There's a whole lot of fundamentals about Windows internals, a whole lot of fundamentals about CLR internals, and not on the slide, there was a whole lot recently over the break, over the vacation break, on Windows Store apps, about 10 or 15. Watch that. Obligatory sysinternal slide, because I'm using Process Monitor today and ProcDump to help me get to root cause. The slide's there. Great book. Get it, buy it, enjoy it. All right, today we're going to go through 3 phases: collecting, debugging, and tracing. Because this is more of an IT-centric convention, we're not going to go to really through the Dev Center approach. If you want to see that, there's an equivalent talk at Build that I did, which was developer-focused, called Avoiding Windows Store Application Failures. So watch that one for more detail. We're just going to skim over that for a couple of seconds. We're going to go shortly over Windows Error Reporting, what it is, what it does for you, and how there's an associated corporate error reporting. We're going to go through sysinternals ProcDump, which I happen to code for Marko Sinovic. And as of this morning, we just code signed version 7 that's been in development for about 2 years since version 6 came out. And we're going to be using version 7 today and all the new Windows Store application features that it has. Then we're going to get into the damn debugger and do some good console-based stuff, because I don't believe in GUIs. Then we're going to find that, unfortunately, with the Windows Store applications, you don't get very far from a detail point of view, and so you have to augment the dump files through tracing. And ProcDump and Process Monitor in unison, who actually have a buddy relationship, can be used to help you with that. I'm going to mention Windows Performance Toolkit because it should be mentioned in every single deck that